Alright, in this video we're going to take a look at finding conditional probabilities. So, what are those? Well, conditional probability is found by determining the probability based on a previous event happening. So in our last couple videos we looked at using multiplication rule and independent events. In this video we're going to take a look at determining conditional probability, which is based on one event already happening or out of a certain given total already. So our notation for the probability that event B occurs, given that event A has already occurred, is this P probability with parentheses like we're used to. And then event B occurs given that event A has already occurred. So this vertical bar, when you see it in the notation, you can replace that vertical bar with the phrase given that, or if. So the probability of event B occurring if A has already occurred, or that B occurs given that A has already occurred. So with conditional probability, our denominator is often going to be the total of something that follows the words if, suppose, or given that. So we'll start by looking for these key words and phrases in the problem. We're going to have one involving tabular data, so data in a table. And we're going to look for these key words, and then we're going to find the total of that event, and that's going to go in our denominator. So whatever event follows these key words with conditional probability, that total goes in our denominator. So that would be the first event already happened, or yeah, the first event here, A, already happening. All right, so example 4, the table below lists the types and number of cars sold at Lemon Autos along with their ages. Find each probability. So a couple things to note on this table. We have them sorted in rows based on imports and domestic cars. And we have their ages as well. So we have between 0 to 2 years, so fairly new cars, 3 to 5, 6 to 10, over 10. One other thing I want to point out on this table is in each of these, we have the row totals for the total number of imported cars and the total number of domestic cars. And we also have the column totals based on their ages. And not every single table is going to give you the row totals and the column totals. So if they don't, then you're going to have to find them. And your row totals, which in this case 100 and 100 is 200, and your column totals 72, 44, 23, and 61, when we add those up, we also get 200, and that should always be the case. So the total you get for the rows should match the total you get for your columns, and you can put that in the bottom right of your table. All right, so let's start example 4, part A. We have, if a domestic car is randomly selected, what is the probability it's between 6 to 10 years old? So our key word here we're going to hunt for is if. So the event that follows the word if is a domestic car is randomly selected. So we want to find how many total domestic cars there are on this lot, which in this case there's 100. So out of these 100 cars, what are the chances we get one that's between 6 and 10 years old? So our 6 to 10 domestic cars, there's 11 of those. So our probability of a 6 to 10-year-old car, given that it's a domestic car, is 11 out of 100. Or that we get a 6 to 10-year-old car out of all of the domestic cars. So 11 of those domestic cars are between 6 and 10 years old. So 11 out of 100, or 11% if you want to go the percent route. All right, part B, what is the probability of selecting a domestic car given that the car is 6 to 10 years old? So now let's see, here we have the phrase given that, and the event that follows that phrase is the car is between 6 and 10 years old. So now we want to focus on, for our denominator total, all the cars that are between 6 to 10 years old. And in that case, there's 23 of them. So notice now, out of those 23 cars, we want to know how many of them are domestic. That's 11 out of those 23 cars are domestic. So 11 out of 23. So a little bit less than 50%, or yeah, a little bit less than 50%, or half. So now switching them does impact what we're looking at as far as our total is concerned, because in the first problem, in the last one, we looked at the total number of domestic cars because this phrase followed the keyword, the domestic car followed the keyword if. But now we have the 6 to 10-year-old cars following the key phrase given that. So now instead of the domestic row total, we're looking at the 6 to 10-year-old column total. So very important that even if we switch them around, that's probably going to give us a different answer. All right, part C. Suppose a new car is selected. So, what is the probability that it is an import? So, new car is selected, follows the word suppose. So, we're going to look at the total number of new cars, which would be our 0 to 2-year-old cars, and that total is 72. So, out of the 72 new cars we have on the lot, how many of them are imported? Well, 37 of them out of 72 are imported. So, the probability that's an import given that, or based on the fact that it's a 0 to 2-year-old car, or it's a new car, is 37 out of 72. So a little bit more than 50% chance that we pick an imported car if we're just looking at new cars. So, all right, that about does it for this video. Thank you for watching. I will see you next time.